Hi everyone, for today's 4-H science activity, we're going to do something called the egg crusher. What we're going to explore is how much pressure a raw egg can hold up compared to a boiled egg. But at a higher level, we're also going to look at just natural adaptations that animals have. Specifically today, the strength of an egg shell. Eggshells seem pretty fragile. If I was to drop it, we know it would break, or if I was to tap it against this metal, it would probably also crack. But eggshells can actually withhold a lot of pressure. For example, a mother hen sets on this, and if eggshells were too weak, they would crush it every time she moves or every time she rolls around. Eggs are most strong from the narrow ends, and that's actually how they set under the mother hen. And we've seen examples of human beings learning from eggs and doing amazing things with architecture and engineering. So for example, the Taj Mahal and other structures like it have domed roofs. And the domed roof is modeled from an egg. The reason eggs are so strong is because they distribute the pressure throughout the entire surface, whereas a flat roof, the pressure is put in one point. So what we need for our egg crusher activity today is just a few simple materials. First, we have some boards here. This one's a little bit fancier than it has to be. What we've done is we have two long boards, we have a narrow board, or short board here, and we've attached that with some hinges. You're also going to need some padding because we're actually going to compress the egg between these two boards. And if there's no padding, the hard surface could crack the egg. Or for example, if you just dropped it a little bit, it might crack the egg. So these are really important when you're doing this experiment. You can use different materials. You can do, this is like a rubber coaster for the bottom of a chair's leg. This is simply the bottom of an egg carton. We just cut that out in a circle. I like to use bubble wrap because it gives a little extra cushion. So you'll see we've taped this bubble wrap here to the bottom at the top of the board, and we've actually put it on the edge. And that's where I'm going to place the egg for this video, is on the edge, so that you can see it. When we do this with kids, we're going to place it in the middle because the kids are actually going to stand on here, and if it was on the edge, the weight would not be distributed properly. There's a couple important safety tips that you need to know when you're going to have kids work with this, because the kids are actually going to stand on the egg sandwich. First, you want to have two children, or at least one, helping their friend get up on top of the board. As the children are getting on top of the board, you as the instructor or volunteer leader want to just help balance just a little bit until they can carefully and comfortably put their weight on it. And then as their friends are holding it, they'll be able to stand fully and completely on the board. A few last-minute materials you want to have in mind are paper towels, because as raw eggs break, you can sometimes make a lot of mess. You may also want to place some drop cloths down, newspaper, a tablecloth, just a blank piece of paper, anything will work. And you may also like to have some sort of splash guard, especially when you're working with the raw eggs, because some of that yolk may get on your clothes and that can be a mess sometimes. So that's it. Let's take a look and see what happens. It should be fun. Why does a chicken lay an egg like this if it's so fragile? I mean, what's special about eggs to help them hold up chickens? Even though the weight's pressing here, all the little cells in the egg are actually taking on some of that weight. Look at this, isn't this a beautiful building?
Oh my gosh.
And look, isn't it neat how it's kind of designed after the shape of an egg?
It's just the thing in Australia.
Here's another one that scientists or engineers might have designed from an egg. It's called the Gherkin Building, and it's in London. Isn't that cool? Which is stronger, a raw egg or a boiled egg? I want to know which can hold more weight. That's my scientific inquiry. And so you guys today, we're going to test it. 52. So let's see if it can hold 52 pounds. Okay, you ready? I'm going to kind of balance the board. Okay, go slow, nice and slow. You can step on this, okay. Keep going. Oh, ooh.
It's
52 pounds. Okay, very carefully. Let's try 60. Let's try 60. Here we go. Here we go. Oh, oh, I'm gonna let go. 60 pounds. Here we go. We're gonna try 75. Okay, here we go. Shh, I'm gonna let go of it. Oh! So as you can see, there's really nothing more fun than watching an egg explode. The kids had a lot of fun with that. And you saw some great science inquiry taking place. They were making observations, they were recording data. We even got to more questions. You know, the kids explored which is stronger, a hard-boiled egg or a raw egg, and they saw a raw egg was the strongest. But then they got into maybe brown eggs are stronger than white eggs. Maybe different kinds of bird eggs are stronger than others. And that's really what science inquiry is all about. Now what we're going to do is I want to show you a couple different versions of this activity. It works really well with older kids. It works well with young kids too. So let's do that. Let's take a look at it. This is, the alternates are really good, especially for older youth. You saw that we asked the kids, how much do you weigh before they got on the egg sandwich? And sometimes for older kids and adults, we're uncomfortable telling people what our weight is. So this is a different version that allows kids to not have to tell people their weight. And it also will allow them to be a little more accurate with the amount of weight that they're measuring. Because for example, in our activity we said, just kind of estimate how much you weigh. With older kids, we want to get more detailed. So what we have here is just like before, we have a long board and we have some boards on the back. And I'll show you. I just laid some boards on the back to raise it up so it'll be level. And I had a couple more boards here, again to build it up so it's level. And we're going to place our egg, as we did before, under this long board. And I used some different padding this time. I used the bottom of an egg carton. So I'm just going to put one on the bottom, one on the top, and we'll lift it up, and then carefully lay it under. And you can see how I laid it under here. Now I'm going to slide it to the middle because remember, we want it to be in the middle when we do this, so it distributes the weight more evenly. And it's always key to make sure that the egg is straight up and down, because if it is uneven, remember, the wide ends are much weaker than the narrow ends. So what we have here are actually some different pop or juice bottles filled with sand, and we've actually measured the exact weight in ounces of each. This is 24 ounces. You can see here we have 3 ounces, 8 ounces. And when you're doing this with kids, you want to start off with the smallest weights first and ask them, how much weight do you think this can hold? And then they slowly build the weight up onto the board. And so let's see, let's do it really quick. There's about 50 pounds in here, give or take. Now kids don't know this, but this board will actually hold up, or this egg will actually hold up all of this weight. And I could just keep stacking it, and it will hold everything that's in this. So you can make more, and you can go to the point that it actually does break to see just how much weight that can hold. So that's one version that works really well with older students. And they can have the exact weight there, remember, so they can measure that on a graph or on a table, however you would choose to have them record that. I want to show you this one. This is what we call the Egg Compressinator 8000. And just like before, these are things you can find around the house or the hardware stores. Now for this one, because we do have a lot of moving pieces here, we do want to put kind of a splash guard so that when the egg breaks and the yolk runs everywhere, it doesn't get all over our jack and scale. And again, as in the last one, I've taken some, the bottom of egg cartons. This works really well for this one. A neat thing you can do is also have, especially when you're working with teens, you can have teens design things like this so they can make their own Egg Compressinator 8000. So we're actually going to test it, and remember, you want to keep the narrow ends up. So I'm going to move it back just a little so it's in here. Okay, so now we actually have pressure on here. Now with this model, because there's so much force exerted at the top and bottom of the egg, it's gonna break sooner. So let's see how many pounds this can hold. And this is great. Let kids do this, especially older kids, let them center the egg, let them figure out through trial and error what works best. That's all part of the inquiry process. So now I'm up to about 20 pounds, and it broke at about 25. So 25 pounds of pressure at the very top and very bottom before this egg broke. So those are just a few alternates on that very simple experiment, comparing raw and boiled eggs. And remember, you can compare a lot of different things with eggs, color, different species. And also, what else could you crush in this? Nuts, fruit, who knows where you could take it. The kids will take it in all kinds of great directions, and that's all that science inquiry is all about.